Assalamualaikum warahmatullahi wabarakatuh and welcome to my channel. In this video, we are going to discuss one method that we can use to solve SLE, that is system of linear equation, by using Cramer's rule. Okay, the name of this method is taken from the name of a Swiss mathematician that is by the name Gabriel Cramer. Okay, that lived in the year 1704 up to 1752. Okay, he is a Swiss mathematician. All right, so since this method is extensively using the determinant of a square matrix, therefore, okay, before we proceed with the method, we are going to explain a little bit how to find the determinant of a 2 by 2 matrix first. Okay, as we know, determinant is only exists for a square matrix like 2 by 2, 3 by 3, 4 by 4, okay, matrix like that. So for example, for a 2 by 2 matrix, okay, in general, if we have matrix A having element A, B, C, D like this, okay, we can find the determinant of this matrix by writing symbol like this. Determinant of A will be equal to A multiplied by D, and then we subtract B, okay, we subtract the product of B and C, okay, AD minus BC. That will be the determinant of a 2 by 2 matrix. All right. Now, example number 1, maybe we can explain a little bit more about the formula. So 2 by 2 matrix also here. So we would like to find the determinant of matrix B. Therefore, the determinant of B, write it like that, equal to AD minus BC, right? Okay, the value for A in this matrix is 3. Okay, multiplied by D. D is 7 minus, okay, B is negative 4, and C is equal to 2. So we have here 21, okay, plus 8. This is equal to 29. Okay, as you notice in this example, that the determinant of a matrix is always a number, like 29, whatever number is supposed to be a number like that. So this is an example of finding the determinant of a 2 by 2 matrix. Now for 3 by 3 matrix, like this particular matrix here in general, call this matrix C, okay, having element A, B, C in the first row, D, E, F in the second row, and G, H, I in the last row or the third row. Okay, so how to find the determinant of a 3 by 3 matrix? What we have to do is, okay, let's copy again, okay, these numbers, okay, the element inside matrix C, A, B, C there, A, B, C, and then we have also second row, we have D, E, F, then we have G, H, I. What we do next is we are going to copy, okay, the first column, that is this column, and also the second column, and write it on the right hand side of the matrix. What I mean is we write like this. So we copy and write again the first column, that is A, D, and G. This is the first column. Now the second column, B, we have E, we have H. Alright, so I hope you follow what I'm doing here. I just first copy all the element of the matrix, okay, and write it over here, and then we add 2 more columns. That is the first column, copy the first column and write it on the right hand side of the matrix, and also the second column. Now once we do that, okay, we are going to multiply these 3 numbers like this, going down. Okay, all the number on this arrow, that is A, we have E, and we have I. So we have to multiply these three numbers. And then, after we do that, we are going to multiply these three numbers also. Next row. And the third row. The third arrow, I mean. So what we do is that we are going to multiply. We have A, EI plus, that's the first product. We have A, we have E, and we have I. Multiply them. And then add that product with, okay, all the numbers that in the second row. That is, I mean, the second arrow, I mean. So we have B, we have multiply by F, and then multiply by G. Now, after we multiply that, we have to multiply three more numbers. That is C, we have D, we have H in the last arrow. So we have C multiply by D multiply by H. Okay, add all these numbers together. Okay, multiply, then add them up. Then we have to subtract, okay, the numbers that is on this arrow. Okay, this is the first arrow. That is, we multiply G, multiply by E, and multiply by C. Okay, then we add with the number on this arrow. That is H multiply by F and multiply by A. Okay, like that. Need more space here. Then we have to add with the product of the numbers on this arrow here. That is I multiply by D and multiply by B. Okay, like that. I hope you understand what I'm doing here. Okay. Okay, after that, we find the sum of all the numbers on the first in the first bracket. Find the sum, okay, of the product on the second bracket, and then subtract the number in the first bracket minus the numbers in the second bracket, and then we get the one particular number, and that number will be, okay, the what we call the determinant of C. The determinant of matrix C will be equal to these numbers minus that numbers. Okay, maybe we can clarify that formula by using this example here. We are given matrix D equal to, okay, maybe you can read in terms of row 2, 4, -3, -1, 0, -5, -4, 3, and 1. The question is, we want to find what is the determinant of matrix D. So maybe we can do the calculation on the right hand side over here. So let's copy the first row. That is, we have 2, we have 4, we have -3. First row. Second row, we have -1, we have 0 there, and we have -5. Okay, last row, we have -4, we have 3, and we have 1. Now, what we do next, as I explained before, that we have to copy, okay, the first column. That is, I want to write it over here. 2, -1, and -4. Like that. And the second column also. That is 4, we have 0, and we have 3. Okay, I already copied the first column and also the second column. Now I'm ready to write down, okay, the calculation to find the determinant of D will be equal to, okay, maybe you can use this bracket here, 2 multiplied by, okay, the numbers on this first arrow. That is 2 multiplied by 0 multiplied by 1. plus. Now the second arrow will be this, and the number on this arrow will be multiplied. That is 4 multiplied by negative 5 multiplied by negative 4. Now my third arrow will be this one, and the number on that arrow is what? Negative 3 multiplied by negative 1 multiplied by 3. Okay, we are going to multiply each one of these, and then we want to add them up. Okay, now subtract. Minus what? Okay, we are going to draw an arrow going upwards, going up like this. So the first arrow is this, and the number on that arrow is, we have negative 4 multiplied by 0 and multiplied by negative 3, right, plus. Now my second arrow is this, and the number on that arrow is 3 multiplied by negative 5 multiplied by 2, plus the last arrow will be this one, that is 1 multiplied by negative 1 and multiplied by 4, and I want to close the bracket. Now let's simplify this and see what we get. Okay, is equal to, okay, in the first bracket we have 0 there. We have 20 times 4, we have 80 there. And we have here, we have 3 times 3, 9. Okay, minus. Now in the second bracket we have 0. We have negative 10, negative 30. And we have negative 4. That is equal to 89, okay, minus negative 34, equal to 89 plus 34. This is equal to 3 there. Oh, 123. Yes, that is the determinant of matrix D. Okay, therefore we conclude that the determinant of matrix D is equal to 123. Okay, now this example is very important because we are going to use this method. Okay, whenever, maybe in the next example after this, we are going to use this method to find the determinant of a 3 by 3 matrix. Very useful method. Okay, this particular way is very simple. There are some other way also we can find the determinant of a 3 by 3 matrix, but I think this one is the simplest one. Okay, the rule is simple. Now after discussing about finding the determinant of a 2 by 2 matrix, to find the determinant of a 3 by 3 matrix, since Cramer's rule is stressing so much on the determinant of a matrix, so that's why we explain first how to find the determinant of a 2 by 2, 3 by 3. Okay, and also they have the determinant of 4 by 4 matrix, but we are not going to discuss it here because it will take a lot of time to show to find the determinant of a 4 by 4 matrix. Okay, maybe that one we better use calculator, or maybe we can use a software to solve it for us. All right, now Cramer's rule for a 2 by 2 matrix. When we have a system of linear equation with two equation and two unknown like this, see here. All right, this system having two equation and two unknown. The unknown is x, and the other one is y. We have the right hand side green in color here, P and Q. That's the right hand side of the equation. Okay, now to use Cramer's rule to find the value of the variable. Okay, I hope you still remember. That is, when we are trying to solve a system of linear equation, meaning we want to find the value of the variables, right? Like in this example, or in this formula here, in this system of linear equation, the variable is x and y. Therefore, Okay, when we try to solve this system of linear equation, meaning we are trying to find the value for x and also the value for y. So if we use Cramer's rule, okay, we have to use this formula. It has a very important formula, that is to find x. X will be equal to the determinant of Ax divided by the determinant of matrix A. Again, I repeat, okay, the value for x, that is our first variable, is equal to the determinant of matrix Ax divided by the determinant of matrix A. I'm going to explain in a short while what we mean by matrix Ax. Alright, that's for x. Now, the other variable, that is y, can be found by, okay, by using the determinant Ay, the determinant of matrix Ay, we have to divide it by the determinant of A also. You see here, in finding the value for x, we have to divide by the determinant of A. Okay, to find the value for y, we have to divide, okay, by the determinant of A also. The only difference is at the numerator. Here, to find the value for x, at the numerator we have the determinant of Ax. To find the value for y, the numerator is the determinant of Ay. That's the only difference. We have to divide by the same value, that is the determinant of A, and also by the determinant of A over here. Okay, that's the formula. Now, I need to explain what we mean by matrix A, matrix Ax, and matrix Ay. Actually, in this formula, we have three matrices. Number one, matrix A. What we mean by matrix A in this formula is that just the coefficient of the variable x and y, column wise. So the coefficient for x is, okay, A and C. The coefficient for y is B, B and D. Okay, that will be matrix A. So whenever you see matrix A, that is over here at the denominator, okay, over here also we have the determinant of matrix A. What we mean by matrix A is this matrix, that is the matrix consists of, okay, the coefficient in terms of column. Yeah, column wise we have AC, that is the coefficient of x, and we have the second column, that is BD, that is the coefficient of y. So this is matrix A. Next, we need to explain also what we mean by matrix Ax. Matrix Ax is like matrix A, but with a small modification. We have to remove, okay, all the coefficient of x and replace it by the right hand side. What I mean is, okay, it's like matrix A. We have A and C here, but we have to remove A and C and replace by the right hand side. That is, we write P, Q, remove this column and replace by P and Q, the right hand side of the equation here. And we copy or write the same column for the second one. That is column, we have B there, and we have D over here. Okay, that will be matrix Ax. Now, can you guess what is matrix Ay? Can you guess what is matrix Ay? Yeah, of course. Okay, it's like matrix A, but we have to remove the coefficient of y, that is B and D, and replace it by the right hand side. And so the first column is still the same, that is we have A, C there. AC is still the same, but for the second column we are going to replace it by the right hand side, that is P and Q. P and Q, like that. So once we have A, right, once we have A, we can find the determinant of A. Like I mentioned, okay, a few minutes ago, we can find the determinant of A equal to AC minus AC. Okay, maybe you can write it down over here. So the determinant of, from here we can find the determinant of A, right? Determinant of A is equal to AD minus BC. From Ax, we can find the determinant of matrix Ax. It will be equal to P times D minus B times Q. From AY, we are going to find the determinant of matrix AY. That will be equal to A times Q minus P times C. Okay, and then once we have all these determinant for these three matrices, we are going to replace it into this formula to find the value for X. We are going to divide the determinant of Ax by the determinant of A. Okay, Y is equal to the determinant of AY divided by the determinant of matrix A. Okay, whatever this value is, okay, we are going to substitute into this equation, and then we can find the value of X and the value for Y. Alright, now that's for 2 by 2. What we mean by 2 by 2 is when we have a system of linear equation with two equations and two unknowns. See, this is two equations. Equation number 1, equation number 2. Two unknown, that is X and unknown Y. Two unknown. Alright, two equation and two unknown. But sometimes we have a bigger system. That is when we have like this one, where we have three equations. We have equation number 1, equation number 2, and equation number 3. Not only that, we also have more variable this time. That is, we have variable X, variable Y, and variable Z. Meaning here we have three equations and three unknown. Now the question is, okay, how to find the value for X, the value for Y, and the value for Z. Okay, so we have three variables here, and we have to find the value for each one of them. All right, so if we follow the formula as I explained for the case of system of linear equation with two equation and two unknown, okay, we can generalize, okay, that idea into this system, this bigger system. Okay, therefore we can write X will be equal to Ax over A determinant. What else? Y equal to the determinant of AY divided by the determinant of A, like that. Okay, not only two variables, we have our third variable, that is Z, right? Now, what is the formula to find Z? That is AZ, the determinant of it, and divide by the determinant of A. Okay, now the idea is the same like when we have two equation and two unknown, but this time we have three unknowns, so we have to find X, we have to find Y, and we have to find Z. Therefore, in this formula, we have AZ. Okay, previously we have AX and AY only. Now, what we mean by A in this formula? What we mean by matrix A? What is matrix A? It's just the coefficient of the variable, right? In terms of column, we have A, we have D, and we have G. Okay, that's the coefficient of X. The coefficient of Y, we have B, we have E, and we have H. The coefficient of Z, we have C, and we have F, and we have I, like that. Therefore, after we have A, right, we can find what is the determinant of A, because we need the determinant of A. Okay, because we are going to substitute the determinant of A over here at the denominator 3 times. Over here once, second one, okay, third one, we are going to use the determinant of A 3 times in that formula. So we have to find the determinant of A. Now, how to find the determinant of A? Remember, I already explained example number 2, how to find the determinant of A. Okay, by using arrow. Okay, 3 arrows going downwards, and then we also have 3 arrows going upwards. Okay, Like this one, yes. Okay, we are going to find the determinant like this. We have 6 arrows all together, 3 downwards and 3 upwards. All right, so that's matrix A, right? So on the right hand side of this equation, we have P and Q and R, right? So we can write down matrix AX, right? So what is matrix AX? Equal to, we are going to replace the first column with the right hand side, that is P, Q, and R. And everything else the same, like matrix A. So we have B, we have E, we have H. Okay, the third column also the same, that is C, we have F, we have I, like this. Okay, that's matrix AX. 3 by 3 matrix also. Can we find what is the determinant of matrix AX? Of course can. Okay, by referring the example that I showed to you in example number 2. Okay, by using arrows 3 downward, and then 3 arrows upwards. Then we subtract whatever the product and the sum of it. Okay, we can find the determinant of AX. Oh, we need 2 more matrices. That is, we need also AY. All right. So maybe we can write it down here somewhere. So what is AY? We need AY. Let's see AY. It's like matrix A, that is, but we are going to replace the second column by the right hand side. So we are going to copy like the first matrix A. So we have A, we have D, we have G. Now for the second column, we are going to replace by PQR. PQR. Now the third column is still the same. That is C, and then we have F, and then we have I. This is matrix AY. From this matrix, we can find the determinant of matrix AY. I hope, okay, you understand what I mean. All right, up to this stage. Now we have matrix AX, we have matrix AY, and lastly we have matrix AZ. Okay, we have matrix AZ. What is matrix AZ? The first column is still the same. That is A, we have D, we have G. The second column is still the same. That is B, E, H. We have B, E, H. But the last column, that is column number 3, that is the coefficient of Z, we are going to replace it by the right hand side of the equation. That is P, Q, and R. Okay, this is matrix AZ. Now from this matrix AZ, later on we can calculate what is the determinant of AZ. Use and follow the example that I have shown to you in example number 2, how to find the determinant of a 3 by 3 matrix using 6 arrows, 3 downwards and 3 upwards. Multiply all the numbers, okay, on the arrow. For the first one, add them up together. For the 3 arrows going up also, we have to multiply them and add them up together, and then okay, the first bracket minus the second bracket. I hope you understand what I mean. Okay, and maybe you can refer to example number 2 again. All right, now okay, the time is already arrived for us, okay, to explain, okay, Cramer's rule by using this example number 3. Now this system of linear equation having 2 equation and 2 unknown. Equation number 1, equation number 2, and we have 2 variables, that is x and y. Okay, so we can find x, write down the formula, that is the determinant of Ax divided by the determinant of A. Okay, that's for x. Y is equal to the determinant of AY. We are going to divide by the determinant of A. Now we have to find each of these matrix. Now what is matrix A? Matrix A is equal to 8. We have 5 there. We have 4 over here. And we have negative 4. Okay, from here we can find what is the determinant of A. Let's find the determinant of A equal to 8 times negative 4, negative 32, okay, minus 10, minus 10. This is equal to negative 42. That is the determinant of A. Now let's write down the matrix Ax. Matrix Ax is equal to, okay, we are going to replace the first column by the right hand side, that is 2, negative 10. The second column is the same, that is 5. We have negative 4 there. Now from here, can we calculate the determinant of Ax? We have 2 times negative 4 is negative 8. Wait, this is the determinant of Ax. Determinant of Ax equal to negative 8, okay, minus negative. Now 10 times 5, negative 50. Negative 50. Alright, so this is equal to negative 8 plus 50. That is equal to 42. Okay, now for AY, matrix AY, no, this is just the matrix, not the determinant yet. Okay, we are going to find the determinant over there. So what is matrix AY? AY equal to, okay, the first column is the same, that is 8 and 2. Now for the second column, we are going to replace by the right hand side, that is 2 and negative 10. Okay, from here we can find the determinant of matrix AY. So the determinant of AY is equal to 8 times negative 10 is negative 80 minus 2 times 2 is 4 is equal to negative 84. Okay, so we already completed finding the determinant of these three matrices. We are ready to substitute the value for this determinant in this formula. Alright, so to find the value for x, okay, to find the value for x, I want to show it over here. So we want to write down the value of x equal to the determinant of Ax divided by the determinant of A. Okay, that is equal to the determinant of Ax. We have 42 over the determinant of A over here, negative 42. Okay, therefore we already find the value for x is equal to negative 1. Okay, that's the first variable, that is x. Now for variable number 2, that is y equal to the determinant of ay divided by the determinant of a. And we already have the determinant of ay, that is here, negative 84. So we write down negative 84 divided by the determinant of A is equal to negative 42. Okay, it's become positive, and 84 divided by 42 is equal to 2. Alright, so we already have the solution. Solution is x equal to negative 1 and y equal to 2. Okay, maybe we can check our answer whether it is correct or not. Substitute here x equal to negative 1. Okay, 8 times negative 1 plus 5 times 2. Let's see, we have here negative 8 plus 10. We have 2, right? Oh yes, the same like this number. So our solution x equal to negative 1 and y equal to 2, okay, is correct. Right. Now, let's see this example. Okay, in example number 4, we still have a system of linear equation with two equation and two unknown. Still, we want to use Cramer's rule and see what happened uh, in this example here. See, so we have matrix A. Let's write down matrix A over here. Matrix A is equal to we have 2, negative 3, and we have 3 down here. We have 5. Right, 2, negative 3, and 3, 5. So the determinant of A is equal to 2 times 5. 2 times 5 is 10. Okay, plus 3 times 3 is 9. So it's equal to 19. Alright, so we have 2, negative 3, 3, 5. So 2 times 5 is 10, minus 3 times negative 3 is negative 9, so it become plus 9, so it become 19. Right, for matrix Ax is equal to matrix negative 16, we have 14, okay, and we have negative 3, and we have 5 there for Ax. Now, let's find the determinant of Ax equal to what? Okay, negative 16 times 5. This is negative 80. Now become plus 14 times 3. 4 times 3 is 12. Okay, is 42. Become plus. Alright, what is negative 80 plus 42? Is become negative negative 38. Now, that's the determinant of the determinant of Ax. Now, the determinant of Ay, let's write Ay first. Ay, matrix Ay equal to, we have 2, 3, and we have negative 16, and negative 16 and 14, like that. From here, we have the determinant of matrix Ay. That is equal to 2 times 14 is 28. Okay, negative with negative become plus. 16 times 3 is 48. Now 48 plus 28, we have 6 there. 4 plus 2 is 6. 6 plus 1 is 7. Okay, 76. Now let's calculate now, because we have everything, all the determinant of A, Ax, and Ay. We are ready to write down the value for A. Okay, let's write it over here. So we want to find the value for x. X equal to determinant of Ax divided by the determinant of A. Okay, that will be equal to, the determinant of Ax is equal to negative 38, and divided by the determinant of A is 19. Okay, and the answer will be negative 2. Now to find y will be equal to the determinant of Ay divided by the determinant of A. The determinant of Ay is equal to, we already got 76. Right. And we are going to divide by 19. Okay. Now, what is 76 divided by 19? 76 divided by 19 is equal to 4. Okay, there you have it. The value for x is negative 2, and the value for y is equal to 4. All right. Okay, we can always check the answer. Okay, and substitute in equation number 1, equation number 2. We can check, okay, whether it is equal to the right hand side or not. Now in example number 5, here we have x plus 2y equal to negative 3. 2x plus 4y is equal to 1. Okay, in this example, we look here, we have, you see, this line, actually when we sketch the graph of this, this will be a straight line. The second one also will be a straight line. You see, when we divide equation number 2, this is equation number 1, let's call this one equation number 2 here. Now, if equation number 2, we divide by 2, what we'll have is, we have x, okay, plus 2y equal to 1 over 2. Okay, if we divide equation number 2 by 2, you see the right hand side, the left hand side of this equation number 1 and the left hand side of equation number, let's call it equation number 3, they are the same. Meaning this line, but the right hand side, they are not the same. Here we have negative 3, here we have 1 over 2. Meaning these two equations, okay, they have the same slope, okay, but intercept y-axis at different point. They have, what I mean to say is these two lines, they are parallel, okay, meaning they don't have solution. Now if we find, okay, if we trying to find the what we call the matrix A, we have matrix A will be 1, okay, by considering the first equation and the second equation only, the original equation I mean. So we have 1, 2, the first column, and we have 2, 4. We'll have, okay, the determinant of A is equal to 1 times 4 is equal to 4. 4 minus 2 times 2 is 4. Is equal to 0, you know. But we already know that this system of linear equation, okay, since the two lines, they are parallel, okay, they don't have solution, or there is no solution. Now the determinant of A itself is equal to 0. Now let's see on the next next example here. We have, all right, now okay, now let's say this is equation number 1, this is equation number 2. If we multiply equation number 2 multiply by 2, what happened? We have 4x minus 2y equal to 5. Let's call this one equation number 3. Now what we notice here is that equation number 1 and equation number 3, they are the same equation, right? Meaning this line and this line, it is overlapping, okay, it is the same line overlapping. We have in this case infinitely many solution. Now let's find the value of what we call the determinant of A. First find A first, right? The matrix A is equal to, first column 4, 2, second column negative 2 and negative 1. See what happened. The determinant of A is equal to 4 times negative 1 is negative 4 minus, okay, 2 times negative 2 is negative 4. We have negative 4 plus 4 is equal to 0. Okay, we already know because this line, they are overlapping. This is the case where we have IMS, that is infinitely many solution. Okay, and we are going to have determinant of A is equal to 0. For the case where we have no solution also, the determinant is equal to 0. Remember how to find x, right? To find x, what we have to do is x equal to the determinant of Ax divided by determinant of A, right? The same thing for y is equal to the determinant of Ay divided by the determinant of A also. But in this case, the determinant of A is equal to 0. We are dividing by 0. Okay, we are dividing by 0, which is undefined. Now, for the case of no solution, also we get the determinant of A. In this case, the determinant of A is also equal to 0. So to find x, we are also, okay, dividing by the determinant of A, and the determinant of A is equal to 0. We are also here dividing by 0, in which it is also undefined. What I mean to say is, when the system of linear equation, okay, is either no solution or infinitely many solution, this method, that is Cramer's rule, okay, is failed, meaning we cannot use it. Okay, we cannot find the solution when the system is no solution or infinitely many solution. This method cannot distinguish. Okay, when we have the solution is infinite many, at the same time when there is no solution, Cramer's rule cannot tell, okay, which one is no solution or whether our solution is infinitely many. So Cramer's rule is good when the solution is unique, only one solution. Okay, lastly, let's explain, okay, example number 7, where we have a system of linear equation with 3 unknown, how to use Cramer's rule to solve it. So I'm not going to solve it up to solving until we get x equal to, solve until we get the value of x, y, and z, because it's very tedious and take a lot of time to do that. Just I want to explain what is matrix A in this case. So matrix of A is equal to, we have first column, we have 3, we have 1, we have 1. Second column, we have negative 2, we have 2, and we have 1. Third column, yes, we have 1, we have negative 2, and we have negative 4. All right, so this is matrix A. Now, from this matrix A, what we have to do next is we have to find what is the determinant of matrix A. Using which method? Remember example number 2, when we have 6 arrows, 3 going downwards and 3 going upwards. Okay, we use that method to find the determinant of A, because matrix A is 3 by 3. We can use that method. All right. Okay, I leave that as an exercise. The same thing for matrix AX. Can we write down, matrix AX only, matrix AX, okay, not determinant yet. Okay, first we write down what is matrix AX. Matrix AX equal to, okay, we replace the first column, that is 3, 1, 1, replace by writing down the right hand side. We have 9, we have negative 5, and we have negative 2. Okay, column number 2 is still the same, that is negative 2, we have 2, and we have 1. Okay, the same thing goes for column number 3. We have 1, we have negative 2, and we have negative 4. This is AX. Now, can we find the determinant of AX? Of course, we can. We can use the example. Okay, refer to example number 2 again. We can find the determinant of AX. What else we need? Yeah, we need matrix AY. AY. AY equal to, sorry, not determinant yet. Okay, we are going to find the determinant later. So now just writing down the matrix AY. The first column is the same, that is 3, 1, 1. The second column, we are going to replace it by the right hand side of the equation, that is 9, negative 5, and negative 2. Okay, the third column is the same, 1, we have negative 2, and we have negative 4. That is matrix AY. Can we find what is the determinant of AY? Yeah, we can. Okay, we use the same method. Now, for AZ, right, for AZ, that is the last matrix that we need. Okay, is AZ equal to, the matrix is, first column is the same, we have 3, 1, 1. Second also the same, negative 2, we have 2 and 1. Now, for the third column, we have to replace it by the right hand side, that is 9, negative 5, and negative 2. Alright, from this matrix, we can find what is the determinant of AZ. Yes. So now we already have the determinant of these 4 matrices, that is the determinant of A, the determinant of AX, the determinant of AY, and the determinant of AZ. Now we are ready, okay, after we get all these values, we are ready to find or to substitute to find the value for x. That is x equal to the determinant of Ax divided by the determinant of A. Okay, we already have, if we do the calculation, you can have the value of Ax, determinant of A, also we have, so we can divide. We can find the value for x. Now, for variable y, we can find by dividing ay, determinant of ay, divided by the determinant of A. Okay, the determinant of z, z, we can use to find the value for z. That is, divide by determinant of az, divide by the determinant of A. Okay, now what we have to do is, we have to find all these values, and then we substitute into this three equation. All these different values substitute in here, we are going to have the value for x, value for y, and the value for z. Okay, I think that's all for now. Explaining how to use Cramer's rule to solve a system of linear equation, where we have two equation and two unknown, and also a system of linear equation having three equation and three unknown. Okay, that's all for now. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.